Okay, this question asked to prove that CD bisects angle AFE. So let's look at the diagram closely. So CD is this line here, and we're asked to prove that it bisects this angle AFE. So we have to show that these two angles, this one and this one, are equal. Okay. Now, the thing you have to do with these is you always have to solve it on the diagram first. So let's look for that proof. We've got a straight line here, and it says that this part of the straight line, this angle is 180 minus x. So this must be x, all right, because the angle sum of a straight line is 180. So if that's x, then that's 180 minus x. All right, so we've got that. Now the other thing is these are two straight lines. CD and AB are two straight lines. So x, this angle here, is vertically opposite this one, which makes that x. Okay. And if you come on the other side of AB, this side, you've got x, you've got 180 minus 2x, and you've got this angle, which will add up to 180. Now, when you calculate the 180 minus x minus this angle, you should get that that's x as well. And then you can conclude that this line does bisect the angle. All right. Now, to write down the proof, okay, I'll angle it this way. All right, here we go. So what did we start with? We said that this angle here, we found this angle here, all right, DFB. So we write angle DFB is equal to, and to find it, you would find it as you normally would if it was numerical, okay? So you'd say 180 minus the angle that they've got there already, which is 180 minus x, okay? And you will get an answer of x. Don't forget to state the property. Angle sum, a straight line. Okay, and the straight line that we're looking at is AB, so we need to state that. All right. Okay, so we found that that's x. Now we're going to write down that this is vertically opposite, so that's equal to the same thing. So we write down that angle AFC, right, AFC is also equal to x for the reason that it is vertically opposite, okay, to DFB. All right. And all we have to do now is find angle CFE, find out if that is x. All right, so on the next line I'm going to write that angle CFE is equal to 180, right, angles on a straight line, take away this angle plus this angle. Okay, and 180 minus 180, 0, minus minus, that's 2x, minus x will be exactly what we're after. That was simplified to x, okay? And therefore, since that's equal to x and that's equal to x, we have to state that, therefore, angle AFC is equal to angle CFE, which is equal to x. Okay. And by the way, we should have stated here angle sum of a straight line. AB again. Okay. And hence, since we've proven that this is x as well, then this line CD is bisecting angle AFE. So hence CD bisects angle AFE, okay, as required, okay, in the question. That's number 8 of 4.1. Let's go to 4.2. I've been asked to show how to find the value of x. Okay, so again, solve it on the diagram. You have parallel lines, okay, And then you've got this angle here in the middle that you can't really apply the properties of parallel lines to unless you do this, right? Draw a parallel line through that intersection there. Okay? Show that it's a parallel line. Okay, so now you have this one, and you've formed alternate angles here and here. So this part here now is 12 because they're alternate, see? Okay. On the other hand, if you look at this parallel line and this one together, you have another pair of alternate angles, and that's that one and that one. All right, so that's 49 there. All right, now 49 and 12, okay, will give you the answer to that question. So x is equal to 49 plus 12, okay, which is 61 degrees. Right, now you haven't been asked to state reasons, just been asked to find the value, and that's what we've done. Same with 1j, you have to find the value. Okay, so 1j, have a look, solve it on the diagram again. We have a parallel line here and one here. And have a look, we have alternate angles. So this whole angle here is 82, all right? All right, but we're only asked to find this y here, this part of the angle. So look at this parallel line and this one, and you'll find that this angle and this angle are co-interior. They add up to 180, all right? So 180 minus 135 will give you 45 in here, all right? The whole angle is 82. We're going to take away this angle here to get y. So y is equal to 82 minus 45, all right? And that will give us 37 degrees. Okay, in question 7, looking at this diagram here, we've got the centre of a circle is O, and AC is perpendicular to OB. Okay, that's given, so we'll just put that in. All right, we have to show that triangle OAB and triangle OBC are congruent. All right, let's solve it on the diagram first. Okay, what can we see? That if that's the centre of the circle, then OA is a radius and so is OC, and they're going to be equal. Okay. We'll see also that OB is common, all right? And we also have a common angle, so we have that AOB is 90 and so is COB, that's given. So we're going to be able to prove this, the two triangles are congruent because of side angle side. All right, so now to write it down. Let's start off with what we said first, that OA equals OC. Let me focus that. That's better. Okay, OA equals OC, equal radii. All right, and then we said that OB was common. All right. And then we also said that angle AOB is equal to angle COB, which is equal to 90 degrees, because that was given. Okay, and therefore triangle OAB is congruent to triangle OBC because of side angle side. Right, that's A. Let's look at B. All right, still focus on the diagram. It says prove that angle ABC is 90 degrees. We have to prove that's 90 degrees. I'll just faintly mark that. Okay? Again, let's try to solve this on the diagram. So, well, you've got 90 degrees here, and you have an isosceles triangle because OC equals OB. They're equal radii. So if you have a 90 degree angle there and they're equal radii, aren't these two angles equal and they add up to another 90 degrees to make the angle sum of that isosceles triangle. So these two are going to be 45 and 45. Okay. Now similarly, this triangle here has the same angles in it, so that's 45 because it is congruent, and that's 45. All right. So 45 and 45 make 90. All right. Now you've got to be able to write that down. So to do that, we simply write that OC equals OB equal radii. Okay, and then angle OCB, this angle here, right, is equal to angle OBC, which is equal to 45 degrees, all right, because they are the base angles of the isosceles triangle OBC. Oops, OBC. Okay. Similarly, you can write that angle OBA is equal to 45 degrees as well. Okay, and therefore angle OBC plus angle OBA is equal to 90 degrees. Okay, and we know that angle ABC angle ABC is equal to those two angles added together. So therefore angle ABC is equal to 90 degrees.